Hey guys, welcome back. So today we're starting a new type of data structure called doubly linked lists. And so in this video, we're just gonna briefly talk about what consists of a doubly linked list, and for example, what the nodes are going to be since they are slightly tweaked. And we're also gonna talk about the append function in doubly linked lists, and the print list function for doubly linked lists as well. So without further ado, doubly linked lists in my opinion are kind of similar to singly linked lists because they both use this concept of nodes, but the nodes for doubly linked lists are slightly tweaked. And so the reason I say that is each node is going to have the next variable or next element in each of the nodes. And so the next element for the A node is the B node. The next element for the B node is going to be the C node. And the next element for the D node will be none. And so on, right? So at the very end of the list, you're going to have none. One difference is that each node also has a prev element or a previous element. And so what I mean by that is if we take the A node, for example, right? This is the head node. The prev element for the A node is also going to be none. The prev element for the B node is going to be the A node. The prev element for the C node is going to be the B node, and so on until we get to the last node where the prev element for the D node, in this case, which is the last node, is going to be the C node. And so one key difference between singly linked list and doubly linked list is that at the very end of the list, the last node is the next, I guess the next thing after our last node is none. And then at the very start of the node, the first thing before our head node is also going to be none. And so basically each node will be pointing in two directions as well. And so we can quickly code that up. We can say, just like our singly linked list, our self.data is going to be equal to the data. Our self.next will be equal to none. And then we're also going to have a self.prev will be equal to none. Prev will be equal to none. And so that is, those are going to be the three elements of our node in our doubly linked list. The data and next elements are the same as before, and our prev element is we're going to initialize it to none. And so for a doubly linked list, when we initialize it, we're going to initialize it the same way as we do a, why do I keep doing that? As a singly linked list. And so our self.head will be pointing to none as well. And so apart from that, I hope that gives you a basic concept of what doubly linked lists are. We'll start going into how to code an append function. And so if you guys want, pause the video and try it on your own. And if you guys have any trouble, definitely come back and we'll work through it together. But hopefully you guys have done that by now. What I'm going to do is in our append function, I'm going to create a new node with the node class that we created up here. And so this is going to initialize the self.data. And remember, our self.next and self.prev are already initialized to none for now. And so the first thing I'm going to handle for it is if the list is empty. If the list is empty, all we want to say is that our self.head is equal to our new node. And we're just going to return. And so that's as basic as it is for appending to an empty list, because we are telling what the self.head should be, and our next and prev elements are already none, so we know that both sides of our first node are going to be none, if it's the only element in the list. If it's not, what we're going to say is that cur is equal to self.head, and just like a singly linked list, we want to loop through to the very last node. So we want to loop through, in this case, to the D. And so we want to say while cur.next, cur is equal to cur.next. And so what this is going to do is we're going to start off at our self.head. We're going to check if there's a next node after this A. Since there is, we're going to loop through to our next node. The cur is now B. And again, we check if there's a next node after our cur. Since there is, we're going to loop through. Now we're at the C. We're checking if there's a node after our C. There is. So we loop through. And lastly, we're at the D node, and we're checking if there's a node after our D. There isn't, because our last thing in this list is none. And so since that will return a false, we're going to go out of this while loop. And now we're at a point where our cur is at the last node. And so what do we want to do now? We want to say that our cur.next is equal to the new node that we created, right? Because we want, say we're appending a, E. What we want to do, we're at the last node. We want to say that our D node will be pointing to the E, right? And then we also want to say, since we have a prev element within our nodes, we want to say the prev element of the E node should be pointing to the D. So it should look something like this, where our D is pointing towards the E, and then our prev element of our E is pointing towards our D. And so all we need to do then is we just need to say our new node dot prev will be equal to the cur. And remember, our new node, the next element of that new node is already none, so we don't really have to handle for that. And so that is all we need to do for appending to a doubly linked list. We're just gonna write out our print list really quick, and so this is just gonna be really similar to our singly linked list. We're gonna say cur is equal to self.head while cur print cur.data, and then cur is going to be equal to cur.next. And so that is going to be our print list function for doubly linked lists. And so first, I'm going to comment out these three. I created a variable with the doubly linked list class, and called the DLL. I'm going to call the append function once, and so I'm going to say dll.append a. And hopefully if I run this, sorry, I'll just close out of this and I'll just open a new terminal. So hopefully if I run this, this will print out the A, which will show that these 3 lines of code are working, and these couple lines of code are also working. So if we run that, we get A, right? And so this was kind of our first case where our list was empty. And so since there was not a self.head, we just set the self.head equal to the new node, and we returned. And then in our print list, we said cur is equal to self.head, and we said while there's a cur node in that current position, we're going to print out the data element, and we're going to move on to the next node. But since the next thing after our head node in this case is, because this points to none, since this points to none, then we just ended the while loop, and that was the end of the print list function. And so that is just if the list was empty. I'm just going to uncomment these 3 lines of code, and if we have done this right, this should run A, B, C, D. And so I'm going to clear out of this really quick, run this, and we get A, B, C, D. And so let's just go through it really quickly. We already added to our empty list when we appended our A. After that, our list was not empty anymore, so we had a self.head, and so we just set our cur equal to self.head. We looped through to the very last node, and we said our last node should point to our new node, and the prev element of our new node should point to our cur node, which is originally the original last node. And then when we print it out, we just do the same thing. We wait till we hit the none at the very end of our list over here. We just wait till we hit that, and then that is the end of the loop, and at that point we will have printed all of the data elements in our list. And so that is what happened here, and we got A, B, C, D. And so that is a quick intro to doubly linked lists. Hopefully that was helpful, and I'll see you guys in the next video. Alright, later guys.